So rational functions, we all know what functions are. Rational functions, if you look at the keyword for rational, it is ratio. And we all know what a ratio is. A ratio is simply, you know, one number divided by another number. So all fractions, so 1/2, 17/2, 37/19, all of those are simple ratios. They are fractions, or rational functions are simply functions where we replace the numbers in the numerator and the denominator by actual functions. So we change those two by some monomial, polynomial, or trinomial. So for example, we all know a linear function y equals mx plus b. So let's just take a line, a simple line, x plus 1, and another line, 2x plus 5. And I'm going to divide the two. So I have a numerator function, and I have a denominator function. And collectively, the numerator function divided by the denominator function is what we call a rational function, because it is a ratio of two functions. So and we could do addition, subtraction, division, multiplication, all of this regular things that we do with a function to a rational function, because by definition it is a function. But there are a few things that are important when we deal with rational functions. So I'll explain it with numbers, and then I'll kind of use a rational function to explain the concept as well. So note, when we multiply 1/2, say, by 5/7, we multiply things directly across. So we do 1 times 5. The numerator gets multiplied with the numerator. The denominator gets multiplied with the denominator. And that would give us 5/14. So I'll call it direct multiplication. Another thing that we like to do when we multiply is to simplify, then multiply. So let's say we had 10/7. So the first step would be to look at the 10 and the 2. 10 would get cancelled by 2. So now I would have 1/1, because the 2 got cancelled, multiplied by 5/7. And we do direct multiplication. Numerator gets multiplied with numerator. Denominator gets multiplied with the denominator. So we have 5/7. So the key here is to simplify, then multiply. When we divide fractions, for instance, suppose we have 3/4 and we'd like to divide it by 5/4. What we do, well, this simply means 3/4 goes in the numerator, and in the denominator, we have 5/4. So we are going to convert this division into a multiplication, something that many of you might know. It's called flipping and multiplying. So we flip the denominator and multiply. So if I flip the denominator, it becomes 4/5, and I multiply it to the numerator. So 3/4 multiplied by 4/5. Then we take one of the two approaches that I discussed in pointers 1 and 2. Either you do direct multiplication if you have nothing to simplify, or you simplify, then multiply. Here, those two would get cancelled. Anytime you cancel in multiplication, you leave behind 1 or whatever number that gets left behind. And direct multiplication, 3 times 1 would be 3, and 1 times 5 would be 5. So when we multiply rational functions, numerator gets multiplied to numerator, denominator gets multiplied to denominator. Always try to simplify prior to multiplication, and when we have division, we flip and multiply. So I'll sort of summarize that. The denominator gets multiplied with the denominator. And always try to simplify. So simplify first prior to proceeding. There are multiple ways to simplify, and I'll show you examples as we go along. So simplification is going to make your life easier. So simplify, and then, you can try to multiply and get the answer. When we divide rational expressions, the key to note here is the concept of flip and multiply. So you've got to flip the denominator, multiply to the numerator. So flip denominator, you multiply to numerator. Okay, one of the key things to watch out for with a rational function is the domain. Why? Anytime we have a fraction, we have to watch out for a divide by 0. We cannot divide a number by 0. In a similar manner, a function cannot be divided by 0 for any value of x. So, which is why we have to find the domain of a function. Because I'll put a remark on the side here. Not all values, oftentimes some values of x may cause divide by 0 with rational functions. And those values must be excluded from the domain of the function. So here we have g of x is equal to 4 minus 3x divided by 2. The only way we would get divide by 0 is if the denominator is 0. But what we have here in g of x is 2, and we know 2 never equals 0. So even though this is one function divided by another function, in this case, we know 2 will never equal to 0. So any value of x can be an input to g of x. So the domain is simply x. X is any real number. Now we have f of x, which is negative 4x divided by negative 2 plus x. Here we're not so sure as to if there is a number which would make the denominator 0. So the way to determine which value could make the denominator 0 is to look at the denominator, which is negative 2 plus x. We set denominator equal to 0. So what we have in the numerator is 2x squared minus 7x minus 4. And in the denominator, we have x squared minus 5x plus 4. The first step is to factor. So I'll do them separately. So the numerator first. So we want to factor the numerator. We have to come up with two numbers so that when we add those two numbers, I get negative 7. When I multiply those two numbers, I get the product of the first and the last coefficient, which is 2 times negative 4. I need to get negative 8. So what are the two numbers? The two numbers are negative 8 and positive 1. Negative 8 plus 1 is negative 7. And if you multiply 2 and negative 4, you get negative 8, which is the same as negative 8 times 1. So we would have 2x squared minus 8x plus x minus 4. Now, in the first two terms, we have a 2x in common. So if I pull that out, I would have x minus 4. In the last two terms, we simply have 1 in common. So if I pull that out, I would simply have x minus 4. Now, I have x minus 4 in common. So if I pull that out, I'll be left with 2x in the first term and 1 in the second term. And that is the numerator. We could do a similar approach with the denominator. We need to come up with two numbers so that when I add, we get -5, and when we multiply, we get the product of the first and the last coefficient, which is 1 times 4. I need to get 4. So the two numbers in this case are -4 and -1. If I add -4 and -1, I get -5. If I multiply -4 to -1, I get +4. So that would equal to x squared minus 4x minus x plus 4. I have an x in common in the first two terms, so if I pull that out, I get x minus 4. Now, whatever factor I have here must appear in the second term so that I can pull it out, just like the numerator part. I had x minus 4 in common. The only way to get that is by pulling a -1 out. So if I pull -1 out, I would have x minus 4. So we have a common factor of x minus 4 and x minus 4. If I pull that common factor x minus 4 out, I would have x in the first term and -1 in the second term. So I could rewrite the numerator as x minus 4 multiplied by 2x plus 1. The denominator as x minus 4 times x minus 1. Those two factors will get cancelled, and we'd end up having 2x plus 1 divided by x minus 1. What started out as a giant expression reduces to a simple expression because there were common factors. So here we have 10 minus 2x divided by 7, and we're going to multiply it to 14 times 5x minus 25. So in 10 minus 2x, I have 2 in common. So if I pull that out, I have 5 minus x divided by 7, 14, divided by, I have a 5 in common in 5x minus 25. So if I pull that out, I have x minus 5. So now I can see that 7 would divide 14 2 times. So I have 2 times 5 minus x divided by 5 times x minus 5. And you may say, oh, that's the final answer. It actually is not the final answer because we can simplify it further. If you look at the numerator and the denominator, 5 minus x and x minus 5 are pretty much the same with the signs reversed. So what we have to do is pull a negative out either from the numerator or the denominator. It really doesn't matter. So I am going to pull a negative out of the numerator. If I pull a negative out of the +5, it becomes -5. If I pull negative out of -x, I have +x divided by 5 times x minus 5. So I would end up getting -2 multiplied by x minus 5 divided by 5 multiplied by x minus 5. Now I have a common factor. I can get rid of it. So the answer is -2 over 5. Here we have a minus 5b divided by a squared plus ab. That is the first rational expression. The second one is b squared minus a squared divided by 10b minus 2a. Make sure you take the time and do it one step at a time. So it would also help if you did it separately until you have very good amount of practice. In the sense, you do the numerator first, the denominator next, and then you divide. So let me start with the numerator, and I'm going to try to do the best I can in terms of factoring. So a minus 5b, there is nothing I could do about it because I don't see anything in common. The second term is b squared minus a squared. Keep in mind that b squared minus a squared is a special product. And we know that that would equal to b plus a times b minus a. So I could write the numerator as a minus 5b times b minus a times b plus a. So now moving on to the denominator, because there isn't much we can do at this point. We have factored everything. Everything looks nice and organized. So we are moving to the denominator. So a squared plus ab multiplied by 10b minus 2a. In the first factor, which is a squared plus ab, we have a in common. So if I pull a out, I'd leave behind a plus b. So if you distribute a back, you'd end up getting a squared plus ab. In the next factor, which is 10b minus 2a, we have 2 in common. So if we pull 2 out, we have 5b minus a. So we end up having a times a plus b times 2 times 5b minus a. Let's put the numerator and denominator together and see if something gets cancelled. So we have a minus 5b multiplied by b minus a multiplied by b plus a divided by a times a plus b times 2 times 5b minus a. A plus b and b plus a are one and the same, so we can get rid of that. If we look at a minus 5b and 5b minus a, they are one and the same with the signs reversed, just like the previous problem where we had 5 minus x and x minus 5. They are one and the same with the signs reversed. So if I pull a negative out, it doesn't matter if you pull it from the numerator or denominator. I'm just going to pull it from the numerator. So negative 1 multiplied by 5b minus a multiplied by b minus a divided by a times 2 is 2a and 5b minus a. So those two will get cancelled. I can distribute the negative back in. Negative 1 times b is negative b. Negative 1 times a is a. So we have a minus b divided by 2a. So same approach, numerator, then denominator. If you have good amount of practice, you don't have to do it separately. I'm doing it this way so that you understand, and the more you practice, you don't have to separate them. I don't separate them. I just know and do it right away. So practice will make you perfect. So numerator, we have 2x squared minus 2 multiplied by 12x plus 36. We have to see if something is in common. In the first factor, 2x squared minus 2, we have a 2 in common. So if I pull that out, I have x squared minus 1. And in the second factor, we have 12 in common. If I pull that out, I have x plus 3. And is that it? Could we do something more? We can multiply the 2 and 12 because they are numbers. So 2 times 12 would be 24. X squared minus 1 is the same as x squared minus 1 squared. And you should immediately realize that that is a special product. Of the form x plus 1 times x minus 1. So I could rewrite x squared minus 1 as x plus 1 times x minus 1 times x plus 3. So that is the best we can do. There is nothing else in common. So we're done with the numerator. Now we move on to the denominator. We have 10x plus 30 multiplied by 3x minus 3. You look at the first two terms in the first factor, we have a 10 in common. So if I pull 10 out, I have x plus 3. In the second factor, we have 3 in common. So if I pull 3 out, I have x minus 1. Now I could combine the numbers together. 3 times 10 is 30. So I have 30 multiplied by x plus 3 multiplied by x minus 1. And that's the best I could do. So there is nothing more to simplify. So we can go back. We have the numerator. So 24 times x plus 1 times x minus 1 times x plus 3 divided by 30 times x plus 3 times x minus 1. So I see an x plus 3 in the numerator, x plus 3 in the denominator, they get cancelled. X minus 1 in the numerator, x minus 1 in the denominator, they get cancelled. So I simply have 24 over 30 multiplied by x plus 1. But both 24 and 30 are divisible by 6. 6 times 4 is 24 and 6 times 5 is 30. So I have 4 there and 5 there. So the answer is 4 over 5 times x plus 1. Now keep in mind, x plus 1 is the same as x plus 1 over 1. So you can combine numerator to numerator and write it as 4 multiplied by x plus 1. Denominator 5 multiplied to the 1 in the denominator, we get 5. So numerator first. We have 18a minus 2a squared multiplied by 4a squared plus 8a plus 3. Oh, sorry, that's 12a squared. We have a 6 in common, so if I pull the 6 out, I have 3a minus 2a squared. And we want to factor the second term. If you factor it, the factors for 4a squared plus 8a plus 3 are 2a plus 3 times 2a plus 1. You should know how to factor trinomials by now. Now, in that term, we have a in common, so I can pull that out. So 6 times a times 3 minus 2a multiplied by 2a plus 3 times 2a plus 1, which would simply be 6a times 3 minus 2a times 2a plus 3 times 2a plus 1. Now moving on to the denominator. We have 4a squared plus 4a plus 1 multiplied by 4a squared minus 9. 4a squared plus 4a plus 1, if you factor it, it would be 2a plus 1 times 2a plus 1. You could easily verify that by foiling. If you foil, you will get 4a squared plus 4a plus 1. Now, the 4a squared minus 9 term, I could write it as 2a squared, which would be 2 squared with 4 times a squared, resulting in 4a squared. I could write that 9 as 3 squared. So what I have here is a special product of the form a squared minus b squared. And we know just from the previous problems that a squared minus b squared is simply a plus b multiplied by a minus b. So we have 2a plus 1 multiplied by 2a plus 1. A is 2a, b is 3. So we have 2a plus 3 multiplied by 2a minus 3. Now we just have to put things together. So numerator over denominator. 6a times 3 minus 2a times 2a plus 3 times 2a plus 1 divided by 2a plus 1 times 2a plus 1 times 2a plus 3 times 2a minus 3. So the 2a plus 1 will get cancelled. 2a plus 3 will get cancelled. And we can see that 3 minus 2a and 2a minus 3 are pretty much the same, but the orders are reversed, so I can just pull a negative 1 out. It doesn't matter, again, whether you pull it out from the numerator or denominator. So I'm going to pull a negative out from the numerator, so 6a minus 1. If I pull minus 1 from 3, I have negative 3. Minus 1 from minus 2a, I have positive 2a. The denominator is 2a plus 1 times 2a minus 3. So in the numerator, I have 2a minus 3. Denominator, I have 2a minus 3. Those two will get cancelled. So the answer would be 6a times negative 1, which is negative 6a, divided by 2a plus 1. We are going to do division of rational expressions and simplifying whatever answer we have. If you understand multiplying rational expressions and if you know the process, division is very easy. All you have to do is to make sure that your first step is correct, and everything after that will follow the procedures that we did in the previous 4 problems. So what do I mean by that? Anytime we divide one rational expression by another, we take the first rational expression, which is, I'll just write over there, a plus b over ab. Since we are dividing that by the second rational expression, we simply flip the second rational expression and multiply to the first rational expression. So that times 4a cubed over 3 times b divided by a squared minus b squared. So now we're just left with the product or multiplication of 2 rational expressions, which is something we have done already. So all we have to do is follow the same process: numerator first, denominator next. So the numerator now would be a plus b multiplied by 4a cubed b. We multiply numerator to numerator, denominator to denominator. Now, I don't see anything in common between those 2 factors. So that's it. We can't do anything else. So I move on to the denominator. In the denominator, I have ab, and I see a squared minus b squared. But we know that a squared minus b squared is a special product. So we have ab multiplied by a plus b times a minus b. And that is the best we can do. There is nothing else we can do. So we just have to combine the numerator and denominator now. So a plus b times 4a cubed b divided by ab times a plus b times a minus b. A plus b would go away. Now, in the numerator, I could write 4a cubed b as 4a squared times ab, using the properties of exponents. A squared times a is a cubed. Divide that by ab times a minus b. Now I could cancel ab, which would result in 4a squared divided by a minus b. Okay, any questions on that problem? You have to try. Doesn't matter if you get it wrong or otherwise. Trying and learning by mistakes is the best way to learn this topic. And practice, of course. You've got to practice a lot, unless, you know, math or algebra comes to you naturally. So let's try this one. The first step here is to flip and multiply. The next step would be to factor those, combine the numerator and denominator, cancel out the common factors. So first step is to flip the second rational expression and multiply it to the first. Then we can take care of the rest. So times, if you flip, the denominator comes to the numerator. And the numerator comes to the denominator. So now we have the entire numerator multiplied directly, the denominator multiplied directly to get a single numerator and a single denominator. So the numerator is x squared minus 4 multiplied by x squared plus 4x plus 4. X squared minus 4 is simply x squared minus 2 squared. And x squared plus 4x plus 4 is simply x plus 2 times x plus 2. The first factor, x squared minus 2 squared, is a special product. So I could write it as x plus 2 times x minus 2 multiplied by x plus 2 times x plus 2. I am going to keep it as is for the time being because there might be a possibility that I can get rid of some of the factors with the denominator terms. So we'll just move on to the denominator and see what happens. In the denominator, we have 3x plus 6 times 2x squared minus 8x plus 8. We have a 3 in common, so if I pull that out, I have x plus 2. And in the second trinomial, I have a 2 in common, so if I pull 2 out, I have x squared minus 4x plus 4. I can multiply the 3 and 2 to get 6. 6 times x plus 2, and x squared minus 4x plus 4 is simply x minus 2 times x minus 2. So we're done with the numerator and denominator. All we have to do now is to combine them together. So the numerator is x plus 2 times x minus 2 times x plus 2 times x plus 2. The denominator is 6 times x plus 2 times x minus 2 times x minus 2. Well, looks like we can cancel those two terms, x minus 2, and there is an x plus 2 in common, so we could cancel that. And there is nothing else to cancel, so we have x plus 2 times x plus 2 divided by 6 times x minus 2. X plus 2 times x plus 2 is x plus 2 squared divided by 6 times x minus 2. And that would be the final answer. I think that should be enough space. Okay. So the very first step is to flip and multiply. So the first rational expression is x squared minus 3x divided by x cubed minus 27. Flip and multiply, so times 2x squared plus 6x plus 18 divided by 2x. So the numerator gets multiplied to the numerator, the denominator of the first rational expression gets multiplied to the denominator. So let's tackle one at a time. So the numerator, we have x squared minus 3x multiplied by 2x squared plus 6x plus 18. In the first factor, we have x in common. So if we pull x out, we are left with x minus 3. And if you look at the second factor, we have 2, 6, and 18. We simply have to pull 2 out, which would leave us x squared plus 3x plus 9. Oh, maybe Amanda was right. We'll see. So, can write this as 2x times x minus 3 times x squared plus 3x plus 9. And the denominator is 2x times x cubed minus 27, which should be 2x. 27, I could write it as 3 cubed. And x cubed minus 3 cubed is a special product. I'll write it here. Recall a cubed minus b cubed is simply a minus b multiplied by a squared plus ab plus b squared. So in our case, a is x and b is 3. So we will end up having two x times a minus b, x minus 3, multiplied by x squared, which is a squared, ab, 3x, b squared, 3 squared, which is 9. So the numerator is 2x times x minus 3 times x squared plus 3x plus 9. The denominator is 2x times x minus 3 times x squared plus 3x plus 9. They are the same terms, so they would get cancelled, and the answer